check the charging. Okay, charging is there. Here. Is voice clear? Little fast comment. Voice clear? I'll start both the questions. Voice is clear? Little fast comment required. You are not responding. Okay, now see, yesterday's class question, I forgot to take the copy, photo I have not taken, I think. So I read the question here. There are two questions yesterday. One is question 1. See, both are yesterday's class. Simply support beam. If I remember, first question, anybody can tell the span for first question? Fast. Span for first question. How much? What is the span for first question? This is A, this is B. Span for first question. I think I should have taken the photo. I have not taken the photo, so it's delaying. What is the span? The first question. 12 meter. There's a point load here. What distance point load, tell me? At what distance from here is the point load? From left end, at what distance is the point load? Distance of point load from left end. Tell me distance first. Where is that point load? Distance from left end. Why this much delay? 4 meter from left end. So, if this is 4 meter, this will become 8 meter. Okay, 8 meter. This point is called C. There is a point load here. Tell me how much is the point load? What is that point load? This is the point C. How much point load? Sufficient for me. Further I won't ask. Then reaction VA is 90 kilonewton. Okay. 90 kilonewton. Then 9 VA and VB, we got it. 1 minute. That I can calculate myself only. I don't have to ask you. See, first, I will close the question today. 4 divided by 12. Your reaction VB is, ink is flowing. Reaction VA is 60 kilonewton. Reaction VB is, the ink is not properly filled. Reaction VB is 30 kilonewton, correct? And when you draw the bending moment diagram, it was 240 here. It is 240 here, 0, 0, 240 here this way. It will come this way. This is the 240. See, 4 meter, 8 meter. Now, again the point A, this point is B, this point is C. Okay, now, if you go to elastic curve, step by step we will do it. See, first I will draw elastic curve here. Some space I will leave here. See, dotted line. Okay. This is initial position. I told you, point load is here. Beam will undergo natural bending. This I told you repeatedly last time. See, if you apply point load here, see the bending of the beam this way. Where the distance is more, that side more deflection will come. This all I told so many times earlier. So go for natural bending. Natural bending. It will come this way. This is the elastic curve. elastic curve. A will remain there only, B will remain, see this blue color is final position. Your C will come down here. C will come down here. This is the deflection at C. If I draw tangent here, this is slope at C, clockwise. Draw tangent at A, see. This is tangent at A. You require a long tangent. Okay, draw it up to wherever you want. Same, tangent at A. If I draw tangent here at B, it will come this way. Tangent at B. Then, this slope is theta A. Yesterday's class, once again you have to go through. Suppose anybody is new to the class, first you study previous class, then only come to this class. Why? It is a continuation. Now, see, what you have to do? Directly, we don't know where is 0 theta. That is the problem. Where is 0 theta, we are not knowing. Symmetry means the center. Therefore, to get slope at A, you find what is this distance. This is, see, displacement, this is tangent at B, displacement of B with respect to tangent at A. Y of what? This is full. From here to here is, I'll put double arrow mark to understand. Displacement Y of B with respect to tangent at A. Okay, here, double arrow mark I will write because one more is coming. This is displacement of A with respect to tangent at B. So first you find displacement of A with respect to B and displacement of B with respect to A. Using displacement of A with respect to B, you apply the trigonometry here. Using this one, you get theta B. Using this one, you get theta A. See here, tan theta A equal to YBA by what? 12 meter. Tan theta B equal to YAB by 12. That's how you got it. Your theta A, theta B came. Okay. For me, no problem. Theta A will came. $800 by EI. Theta A came 800 by EI and theta B came 640 by EI. This already you got answer. Okay. Now, the question is what? Find slope, and this is whatever in the question they ask. Irrespective of whatever they want, you see the question later. Till here is compulsory, I told. Let them ask whatever they want. Whatever they want, these two first you have to get it. Then see the question. See question. They want to find, required to find. Okay, one. First was slope and deflection under load. Under load. That is at C. Okay, now, if you want, once you know, now you know the value of theta A, you know the value of theta B. If you want theta C, you apply the first theorem from A to C. From A to C. Theta A minus theta C equal to area of the BM by EI diagram between A and C. Get the answer. I think your theta C came. Theta A is to 800 minus 800 plus 60 into 16 divided by 2. 320 by EI. 320 by EI. See, this is theta A is clockwise, anti-clockwise, or radians. I won't write radians. Radian, it came clockwise. Then, if you want deflection of C, directly you can't find. You find what is this distance. What is one? Displacement of the point C with respect to tangent at A. How? By, when you want to find deflection at C, directly you can't find. Indirect you have to do. Indirect. Find the value of displacement of C with respect to tangent at A. that value came something. Moment of the area of the BM, use second theorem. Moment of the area of the BM by I diagram between A and C, about C. Then apply tan theta A equal to this full YC plus YCA divided by 4. YCA already known. Therefore, you get the value of YC. YC came. One 1440 by EI meter down, that is the YC value. Correct? Tell me. Correct or not? This is the result we got. All correct? Tell me. All correct? Deflection at C you got 1440 by EI. Tell me. Yes or no? That I am revising now by. No, you tell yes or no. That is the answer came. I am not taking mobile there. If I take mobile there, if I touch the hand some screen, somebody gets blocked there. It is very sensitive. You are not answering. YC is 2 by 60 now. One minute. Check it. Oh, 8 meter law. Oh, 2 by 6. Oh, it is 8 meter. I took 4 meter and 6 meter. Okay. It will come. I got once again now. Where is the answer? Answer equal to 2560 by EI. Okay, over. Now, then they want theta maximum. Second part. Theta max and Y max they want. Theta max is very easy. It is either theta A or theta B. You know theta A, you know theta B. So therefore, your theta max equal to directly 800 by EI radians. Where at left support A it came. Okay. This much already over last time. Correct? Is the screen fully visible or shall I slightly lift it? At A is not visible. At A I will write here. At A. Okay. I think up to here is visible, I think. I have taken the screen little down. Up to this line visible, sufficient for me. No. I will put a light mark there. Up to where visible, up to where not visible. So that I don't have to go each and every time to the screen. Up to here, no problem. Yes, at A. This much is already over last time. Okay, now, last part of the question is to get Y maximum. You write correctly or okay, to get maximum deflection. Deflection. Be a little careful. That symbol is Y maximum. Y maximum. Make a note. What all I tell, make a note. Now, this is unsymmetrical case. What all I tell now you should write. Actually, this I told you in Macaulay's method. Y maximum is not at center. If I see the elastic curve, see, elastic curve here, load is somewhere here. Beam will bend like this. So, this is A, this is B, this is C. First decide whether Y max will take place to right of point load or left of point load. Tell the answer. By looking at the curve only you can tell. Looking at elastic curve only you can tell what? Y max will take place to right of point load C or left of point load C. By look at the sketch. Natural elastic curve. To right of C, very important, right here. First, see, those what procedure, right? First see the elastic curve, draw smooth curve and decide Y max will take place on which side. So answer, see, Y max will take place between, do one thing. See, if you are doing this side, you don't either A to C, don't call C to B. Because when you calculate, we want to come this way. See, when you want something here, we do not want to look left side. If you look left side, trapezium is coming. Anywhere here, look left side. Anywhere here, look right side. So, if I see the bending moment diagram, when you see bending moment diagram, you can make out anywhere here, look left side, triangle. Anywhere here, look right side, triangle. So, we want to come this way, outer to inner. So between, you stayed from that point, between B and C. B and C. Clear? It will take place between B and C. Fully clear? Next question fast I will do. It will come between B and C. Clear or not? Y max will be between B and C. Let the comment. Clear? Okay. Now, that point is not known. So name that point. I will use a red color for that point. Why? It's an unknown point. Where is the red color? Where I kept red color, I don't know. It was having just now here. Fell down. Okay, 1 minute. Okay, not there. Right moment when I want it, I am not getting it. This is so much mix up here, color mix up. 1 minute. Actually, what happens is, when I write something, after finishing, I close the cap by some other color. So, which is black, looks like, actually I was having 3-4 reds here. Yes, right, I know, right time. Whenever I want, I won't get it. This is so frustrating. Color problem. Just a minute. If it continues this way, no, whichever I open the pen is coming black or blue. Where I kept it? Here, by chance. Here, got it. Okay. Now, you call that point as X. X, see. Let Y max be at a point X. See here, comma, at small x from, tell me, if I take small x from B, see now, if I take small x from here, then when I go for bending moment diagram, if I look that side, triangle will come. In case I take small x from this side, when I look that side, oh, problem, triangle and trapezium both will come. So common sense. When you want, I told B to C, anything you want to do, start from that side. So at X from B, B is very, very important. Clear? At X from B, put a big sketch here, space is not there. You write a neat big sketch at X from B. Clear? Okay, now, right, wherever Y is maximum, see, at that point, see now, that is the point X. Actually, the point X is not there. Point X is here. Why? Because actually correct original position here, deformed position is here. Because here you put deformed position, X here. So at the point of Y maximum, you know that slope theta equal to 0. Therefore, slope at X should be 0. So draw a tangent here. See, draw a tangent here. Tell theta X equal to 0. Now, locate X or find X. Find X using the condition that what? Condition that theta X equal to 0. For that, right here, go back to the main diagram. Go back there. Go back there, and carry out all the required marking. I will tell one by one. Come back here. Without disturbing here, see, point X is here. See, this is a Y maximum. Point X, light line. X from here. Without disturbing anything. Then, come slowly down here. This is the bending moment at the point X. Remember, this is X. And this is the point of your maximum deflection. This is Y at the point X. That Y at X itself is Y maximum. There, draw a tangent theta X equal to 0. So, we need what is the bending moment here. So, next calculate bending moment at the point X. Look this side. 30 into X over. It is plus 30 into X. Go back and enter. Enter here. This is calculated value 30 times x. This much fully clear? This much fully clear? Second question you have to do. Okay, now to locate x, see, now the principle what? Our condition is we have to find the value of x so that theta x equal to 0. So use theta x Moore's first theorem. Use Moore's first theorem. See, theta x is 0, you know it. You are that side. Apply from B to x. Next question, it is A to x. I will tell you clearly. See, I want this side. Theorem, consider the points. Consider the points. Which one? B and x. Very important. B and x. Then your statement is theta b minus theta at the point x equal to what? Area of BM by EI diagram between B and x. Okay. Now, theta b is already known. How much? 640 by EI. Theta b is already known. Theta x, you know, is 0. Why? Because it is 0 slope. Area of the BMD equal to half into x into 30x is the area divided by EI. EI will cancel. You get the value of x. Tell what is the value of x in meter. You get 30 into x square by 2 equal to 640 by EI. Tell me what is the value of x. Give at least 4 decimals. Value of x. Solve. Give at least up to 4 decimals for accuracy. Minimum 4 decimal. When you give 4 decimal, you should see the 5th decimal also. You should see the 5th decimal also. $6.53197. That much all not required. 6.53. 4 decimal, 19 becomes 0, 1 will become 2, okay. 6.5320, sufficient. Somebody be laughing. 6.5320 meter, okay. Tell me, yesterday how much I told in the class? What x has to come? Tell me yesterday how much I told? How much I told yesterday's class it should come? What is the value I told yesterday? How much it should come? You tell same is sufficient. What value? Same. It will be always same. Some will tell, oh, this person thinks everything is correct. Yes, everything I do is correct. Okay, x you got. Therefore, those who want, write a statement. Because examination point of view, so many question paper they ask you sometimes objective questions or 2 marks question. Locate where y is maximum. They will not ask how much is y maximum. For those people, you write the answer here. See, answer. What? Therefore, y will be maximum at 6.5320 meter from B. If you present, they will be happy. Option will come. At 6 point something they will tell you, from the load point how much you have to go. From 8 you can subtract. From A how much? From 12 subtract. That's all arithmetic. Over. Now, lastly, 0, no space. Lastly, this is y max location. To get to y maximum. To get to y maximum. What to do? I think now I have slightly changed the screen. I want some space. Okay, I'll manage. To get to y maximum, what to do? See. Directly possible. See here. Extend the tangent. Extend tangent at x. At x. See, this is the tangent at x. See, this is the tangent at x. Extend it to extend to that side support from where x is measured. We are measuring xe. Again, nobody want to look left side where trapezium comes. Extend it to that side support up to where, what? From where x taken? X to B. And mark y of that support with respect to ybx. I will slightly change the screen because space problem is coming. Okay. Slightly I'll change the screen because I am getting space problem. Okay. 1 minute. Little small I will make. Okay. Now okay. But what happens is if it is this way, you can see other things, surrounding things. So what? Subject knowledge, if you see surrounding things, you don't have to bother. That is only those people who go for decoration. I told I never go for decoration. I don't believe in it. Okay, 1 minute. Okay, now board crystal clear. Board crystal clear now, visible fully. Board fully visible now. What all required? I got more space now. Board crystal clear and everything is visible. Up to somewhere here visible, I think. Where? See, now you can see the board visible up to somewhere here. Yes, up to somewhere here. Okay, 1 minute. Yes. Now I got more space. Red I don't want. Okay. Over. See. Now, you have not answered. Clear. Okay. Now, see, if you want y maximum here, what you do is extend the tangent. I will remove this statement of elastic curve. I will tell elastic curve. I will write here. Elastic curve. Next time I will write there. Elastic curve. See, you find what is the value of what? See, this one. Not difficult. See, find what is this value. What is one? See, displacement of B with respect to tangent at x. Y of B. Where is B with respect to tangent at x? Is that ybx itself equal to y maximum? Tell me. Is that ybx? Because this is horizontal, tangent is this way. Is that ybx itself is y maximum? Tell me. Is that ybx itself is y maximum? Yes. Therefore, mark ybx. Remember, not yax, because in case you mark here this one, then when you look this side, you will get a triangular trapezium. This question, that extra x point, since it comes here, refer from that side, so that triangle will come. Okay, now start. Now very easy. Apply more second theorem. Apply more second theorem. Then ybx, red color, really, red color. ybx, that is displacement of B with displacement of B, remember, first point is B, with respect to tangent at x. Tangent at x equal to moment of the area of the BM by moment of area of BM by EI diagram, half sweeping diagram. Between means, be careful, between B and x. B and x, very important. Tell me about which point. When you find ybx, moment of the area of the BM by EI diagram between B and x, about is the most important. About. If you understood everything from beginning of the class, you will fluently tell the answer. About B equal to moment of this area about B. So what you do? Half into x into 30x, half into x into 30x is the area into, we want only this triangle. Its center of gravity is here. We want moment about B. So from B, it is 2/3 of x. Y means I cannot explain. Into 2/3 of x. Divide by EI or equal to, see, 30 into 2, 60. 2 into 3, 6. Okay, no problem. 6. Correct? 6 times what? X into x into x is x cube. X cube by EI or equal to, substitute x equal to how much? Substitute x equal to 6.5320 meter. Tell the answer. 60 by 6 into 6.5320 cube by EI. Tell the answer. By EI. Answer. (2787.01). 2787.01 by EI. Tell me, what is the value I gave you yesterday? Y max, how much should come? Tell me what is the value I gave yesterday. I told you how much Y max should come. Yesterday I told it. Otherwise I'll check once again. Same means you can write the same. Otherwise I made a mistake, possible. Most probably same. What is the value I told yesterday? What is the Y max I announced in the class? Tomorrow how much should come? It was better to tell how much value I announced yesterday's class. Same, thank you. By EI, that is YBX. That YBX, see there, that YBX itself equal to what? You can write here now. Space is really, I will see what is space available. Little space is there. I will write, okay, I will write here. Last statement, I will write here. So, closing part statement, I will write there. We know that YBX, whatever you got, is Y at X equal to Y maximum. Therefore, conclusion, maximum deflection for the beam. Deflection for the beam, Y max equal to 2787.01 by EI meter down. That will be at 6 point, where is it? 6.11. 20 meter from B. Question is over. Completely clear? If completely clear, I will start second question. And that also because your location is changing now. Instead of B, you are turned to other side. If this is completely clear, I will go to second question. Everything is over. First question. Fully clear? Concept solved. Full clear means I will go to second question. Okay, clear. Now, go to second question. Question 2. I will start here. Once again start. Question 2. It is a simply supported beam. I rub and write it. Who want to rub and it will spoil the sketches. Better write once again. See, sometimes it happens. You try to what? Change the values, then full mix-up will come, then something will be forgotten, which will remain as it is. Someone will find out a mistake. He told X from here, then he wrote X from there. Giving chance for people to find the mistake. Why give chance? Rub and write, better. That I am not removing. Okay. I think I can go for a little more space here, I think now. Because I move the camera, little more space is there, most probably. Yes, 1 minute. Yes, up to here, no problem. Yes, up to here. Nothing to worry. Okay, start. Anybody can tell me? Question 2, yesterday's question 2. Yesterday's question. simply supported beam, one by one you have to tell what is the span of the beam. I remember, no, span is 15 meter, I remember it. And point load is somewhere here, somewhere here, right side. The point load is right side. I don't remember what is the point load. Span 15, I know it. This is 5 meter, this is 10 meter. This is your point C. You tell me what is the point load. What is the point load? That I forgot. What is that point load? 180 kilonewton. Oh, not 5 meter, 6 meter. Okay. So, 5 means you get 1/3, 2/3, correct? I changed it. Okay. Who will remember? It is 180 kilonewton. This is the point C at 6 meter from here. 6 meter here. This is 9 meter. Okay. 9 meter. A, B, C. You got the reaction here. The reaction I won't ask you. I will get it. What is there? Why should I ask you? Because you give very late. This time you got reaction VB and we don't comment. I will write the value here. This came 108 kilonewton. This reaction came 72 kilonewton. Then draw the bending moment diagram. 0 here, 0 here. Under the load it is, why should I unnecessarily waste my time? See, I should not waste my time, which is explained so thoroughly last time. It is a waste of time. 648 here. This is the bending moment diagram, which already you got last time. Bending moment diagram. Leave some space there. Sketch the elastic curve. Elastic curve. As usual, elastic curve blue. Remember now load is that side. When the load is that side, see, the bending will take place so that this side more length is there. Where length is more, beam will deflect more. You common sense, you see a building. Where the opening is more, deflection is more. So this time elastic curve will come like this. Elastic curve, see. Therefore, your Y max will be somewhere here. Later now, see. Now, this is the point A, this is the point B, this is the point P. So this is the elastic curve. Elastic curve. Elastic curve. Point A will remain there only, point B there only, point C will come down here. Then draw a tangent at B. I am telling once again the procedure. Tangent at B. This is tangent at B, tangent at B. Draw tangent at A. Tangent at A is also tangent at A, and find what is this distance, what is this distance. These are displacement. This full is what? Displacement of B with respect to tangent at A. This is displacement of A with respect to tangent at B. Here also find same way. Then you find theta A and theta B. You will get the value of theta A and theta B. Theta A and theta B will come. One nimisha. Your theta B will come 2592 by EI radian anti-clockwise. Your theta A will come 2268 by EI radian clockwise. Tell me, then wherever C point is there, this is not C, sorry. Wherever C point is there, C point is there, draw a tangent there. This is theta C. Then to find theta C, apply the First theorem, not C. Now you should look this side. Between what? B to C. Apply first theorem from where? From B to C. Theta B you mark here, anti-clockwise already known. Theta A is already known. Theta B minus theta C equal to area of the BM by A diagram between B and C. That's how we got theta C. This time theta C came anti-clockwise. Theta C came 648 by EI, and to find deflection at C, this is your YC. See, YC, you find this value, that is what? Y of C with respect to tangent at B. You find this value, then apply trigonometry using theta B, get the value of YCB you have to find. YCB, then get YC. Your YC will come 11664 by EI. Tell me, theta A 2268 by EI, theta B 2592 by EI, theta C 648 by EI, YC 11664 by EI. All this value same as last time. This all we got last time. Tell me. 648. Tell me, YC also correct? YC also correct. 11664 by EI you got. Tell me first. The YC value I got, I have not yesterday done. I recap. Is the recap value is correct? This much is done yesterday. No, that 11664, is it correct or wrong? Tell me. Because I do not want mistake. 11664 by EI, YC, yesterday I got the answer. You all told yesterday, we got the answer. You are not responding. Is that YC value I wrote just now, was it the same value written by me last time? Why? Any problem? No response. You tell yes is over. See? One yes from you means over. I can go further. You are wasting time. Just an yes from you means over. I can go further. Because I do not want any mistake in strength of materials. This much difficulty to tell yes or no. Now I get doubt. So I again check now. See? I get doubt. Yes, okay. This much time to get right answer. Okay. This much already over. Then this is yesterday's class. This also yesterday. Theta max is theta A or theta B. This time theta max is how much? 2592 by EI. And remember, it is at B this time. Okay. This much already over last time. Now our class, we are continuing for Y maximum. Okay. Now start. Once again write a sketch. Sketch. See here. This is the simply supported beam. See? This is simply supported beam is like this. Load is somewhere here. When the beam bends, how it will bend? This is A, this is B, this is C. See, full ulta now. The beam will bend like this. Oh, hand slipped. Okay. Bend, we will bend like this. Okay, okay, no problem. We will repair it. This is a bending. Okay, now your Y max will be somewhere here. This will be your Y maximum. Okay, correct? Therefore, this is the point we will take X. Original position here. From here, X. Okay, now, very important. Tell me. Y max will take place between, if it is this side, you tell B and C. If it is this side, tell A and C. What you are right? Y max will be between either right hand to here or left hand. A and C or B and C. Y max will be between which points? Is it between A and C or B and C? Statement is changing now. Once this question is over today, I will give 2 more homework for you. Work out that one, sufficient. Y max between what? Between B and C or A and C. You are not replying. Okay. You are not telling. Between A and C. Where? Let Y max be at X at, see, x from where? See, last time I took x from here. Now, y max is somewhere here. Okay. If I take x from there, triangle and trapezium comes. No. Look this side. So you take x from, tell me, which point you have to take x from? X from where? Y, this is the point x, this is x axis. This is the point x. At x from where? X from A. And wherever y is maximum, your theta x equal to 0. So, let y max be at x from A. That is the point of y maximum, theta 0. Now to locate x or to find the value of x, use theta x is 0. Go back to diagram and mark that point x. That point x is here. Elastic curve, the point x is here. If I draw a tangent here to the elastic curve, see, this is tangent at x. Remember, space is not there. I write here, theta x is 0. So, you last time to locate, see, you applied b to x. Now, you should look from this side, apply the first theorem to locate x. First, before that one, find what is the bending moment at x. This time, your x is from here. Bending moment equal to 72 into x. Now, to get the value of x, theta x 0, use Morse first theorem. You apply a to x now, not b to x. Now, a to x. Theta a minus theta x. Theta a equal to 2268 by EI is theta a. Theta x 0, area of the BM by EI diagram between what? A and x. Half into x into this ordinate, mark here, 72x, this ordinate. Okay, half into x into 72x x equal to 0. This is 2268. Tell me what is the value of x you are going to get. Fast answer. 4 decimal required in meter. What is the value of x you are going to get? Instead of wasting time, I will calculate myself only. 2268 into 2 divided by 72 equal to root answer. 7.9373 meter. 7.9373 meter. 7.93 or 725 meter. Is the value same as what I gave last time? Tell me. Is that location of point x, is it same as last time? No. Is it same as last time what I told? Yesterday before solving only I told, tomorrow what x should come? Yesterday I announced it. Tell me. Is it the same as what I told yesterday? One fast comment yes means I get confidence. Not confidence. Confidence always there with me. I won't get any confidence by these answers. That satisfaction, answer came. Otherwise, see, suppose I complete, then you tell wrong means I can't repair. One yes required. I am confirming. Yesterday or same. Okay. Now, statement. Those who want right. Therefore, y will be maximum at what distance? 7.93725 meter from A over. Now, to get y maximum, extend the tangent at x, not b, up to A and find y of ax. See here. Now, extend the tangent this side, tangent at x this side, and find this distance. What? Y of A with respect to x. 1 minute. Board visible? Y of A with respect to x. Hope board visible. Okay. Now tell the answer. Extreme x. Second theorem. Y of Ax is displacement of A with respect to tangent at x. That is moment of the area of the BMI diagram between A and x. About A equal to, and remove everything now, equal to moment of this area about A half into x into 72x is the area into its center of gravity is somewhere here. 2/3 of x into 2/3 of x. Okay, all x I will put red color. X divided by EI equal to 72 into 2, 144 divided by 3 into 2 is 6 by 6 times x cube by EI or equal to, substitute for x equal to how much? 7.93725 meter. Tell the answer, something divided by EI. Answer. How much? You are not giving answer. So I will calculate. 144 divided by 6 into 7.93725 cube. 12001.11 by EI is the value of this one. Tell me, is it the same answer I announced yesterday? Is it the same answer I announced yesterday or not? Okay. Yes, thank you. So this YAX, whatever you got is nothing but your YX only. Then YX is Y maximum. Therefore, that itself is equal to YX, itself equal to Y maximum. Conclusion. Therefore, conclusion, maximum deflection Y max equal to 1 to 001.11 EI meter down. That will be at what distance? X 7.93725 meter from A. Is both the question crystal clear? Tell me. If both are crystal clear, moment area, further I am not continuing because you can go for 2-point load unsymmetrical, you can do it. Horrible calculation. You can go to any method. Conjugate, you can do it. So limitation is there for this method. This is to understand the basic concept of moment area. In this course, main purpose is understand the basic, not wasting time solving non-stop problems. Full clear? If fully clear, I will do one thing now. Next, we have to go to conjugate beam method, complete new. Today is Friday. Coming Tuesday, I will start conjugate beam method. Very interesting method. And this much confusion is not there. Systematic approach, very simple method. You will make out very clear. So what I will do now is, I will not close the class now. I will give you 2 more questions homework. One question, same as last time question. See, one question, load will be this side. One question, load will be that side. I will directly give answer. I will not give any hint. Problem answer. Can you try and get it today only? Solve these 2 questions thoroughly and make those 2 questions homework. Then you get solid grip then. Okay, start. Homework number 1. Full I remove. No hint, nothing now. Only problem with answer. Directly problem with answer. No hint, nothing. Why? Only numerical difference. Nothing is there. Okay. Two questions are there. Question 1 or question 1, homework question 1, question 2 homework. A simply supported beam of span, I'll take 10 meter, my popular span, 10 meter, is loaded by a point load of 60 kilonewton at 3 meter from left end, AB, over. Next question. A simply supported beam of span, I'll do a small span now, only 6 meter, is loaded by a point load of, I'll give multiple of 9 because otherwise children will come. To avoid children, 36 kilonewton at 2 meter from here. That's all. Question. This is the C. This is the C. For both questions, find what? Slope at C, deflection at C, then theta max and y max. Of course, whatever they want, first you have to find theta A and theta B here. Here also, first you have to find theta A and theta B here. Then only you get the answer. This question, reaction I want. R1 18. This 18. This reaction is 18. This is 42. Okay. Here reaction is 36 into 3 divided by 5. 36 into 3 divided by 6. This reaction is, once again, this is 18. That reaction is 18. I think 18. 36 into 4 divided by 6. This is 24. This is 12. Reaction you calculate. So that if you make a mistake in the reaction, you are wasting time. R1 18. Correct? 42. 36. 1:2. Yes, correct. Okay. Now, this question, one by one answer. See, theta A, theta B is the first step you have to. Then you have to find what? Remaining values. Then you have to find remaining values. Seven meter. Okay. Theta A will come 357 by EI. Correct ಆಗಿದೆಯಾ? ಚೆಕ್ ಮಾಡ್ತೀವಿ ಬನ್ನಿ. Correct. Theta B will come 273 by EI. This question, theta A will come 64 by EI, theta A. Theta B will come 80 by EI. These are the slopes at support. Okay. So this question, then theta max, theta C answer goes there. I'll make easier now. This question theta C, this question theta C. This question YC, this question YC. This question Y theta max, this question theta max. This question Y max, that question Y max. Now, theta max, so already over this question, it is 357 by EI at A. This question, your theta max is 80 by EI at B. Okay, then theta C I want. Okay. $168 by EI. Theta C is 168 by EI for this question. That question, theta C is 32 by EI for this question. If wrong, I will check once again. Deflection at C here. $882 by EI here. YC. Here deflection. $128 by EI here. And Y max here is at what distance from B? Here, Y max is at what distance from A? From A. Here, from B, Y max will be, what is theta B? 273. 5.5 5.5076 meter from B is Y max for this question. That question, Y max is from A. Theta A, theta A 64. Okay. 3.26598 is 60. Fourth decimal. 3.2660 meter from A. Now answer for this question, your Y max equal to this question, your Y max equal to. $796. No, something wrong, because deflection at C I got 882. If I got deflection at C 882, Y mass cannot be 700. 1 minute. 882 correct. Y mass correct. Oh, I'll check that once again. See, I can make out the mistake. One zero, now correct. See, I can make out, because when Y is 882, it can't be 700. 1002.38 by EI for this question. That question, Y max equal to 84. 3.266. 139. Okay, correct. 139, because 8 is the deflection there. Correct? 8. I got little doubt. 1 minute. 36 into 4 into 4 divided by 6 divided by 3. 32. Load is 36. 36 into 2 square into 4 square divided by 3 divided by 6 is 128. Oh, see, this is wrong. This is 128. Correct. I wrote 128 only. That is slope. Correct. I am seeing wrong answer. This is slope actually. Correct. What I did was correct. My answer is correct. 139 is correct, because I thought 8, because from here to here, when you go such a small distance, deflection will not become that much more. But no, I took wrong value here. Okay. Correct. Earlier answer. I get it once again. Theta A is to 64. 139.3487 or 35. Okay, 1 paisa sacrifice by EI meter down. Can you solve both the question? First you solve the 2 class question, make a perfect fair copy, write the procedure, then immediately solve these 2 questions and get complete grip on moment area method for cantilever and simply support beam. Clear? Clear or not? Ensure complete grip, no by hearting, nothing. Clear now? Get the complete grip on this method. So later, any reason, suppose you want to apply moment area method for some odd type of beam, for some reason. Suppose you are teaching somewhere, in exam sometime overhang they don't give actually, complications are there. But if you know this much basic data, you can learn any time. You can learn any time. You will have no confusion. Oh, what is the tangent here? What is the tangent there? Nothing. So therefore, see that last time to cantilever beam problem thoroughly explained. Simply support symmetrical, thoroughly explained. Non-symmetrical, thoroughly explained. Make complete grip on this one. Next time we start conjugate beam method. Clear? I get little time because I have to write something for next FEM class. I have to write some truss problem. So many table I have to prepare. So today class, I want to close at least, I thought 8:30 I will finish. No, it took little more time. Now I used my time for writing for next FEM class. Clear now? Okay, thank you. See you next class. We will start conjugate beam method. By that time, finish all the question given. Thank you. No response. You are not agreed. Yes, we will practice correctly now. And you should tell, now I got perfect grip on this method. That feeling should come. Okay. Shall I close? Okay, thank you.